Now we're going to draw a bolt and nut construction, and both of them are the same, it's just a thickness that is different from one another. The one is a little bit thinner than the other one. First of all, we need the center line position of our construction. And we need also the thickness of the bolt. In other words, it will be indicated by, say, for instance, M40. The M stands for metric, and the 40 stands for the diameter of the shaft of that bolt construction. So what we first of all need is we need an auxiliary view where we can project from to our construction. Let's get the center line for that. Draw the center line for our auxiliary view, and this is the first formula that we're going to use is 1,5 of D. D is the 40 millimeters. In other words, in this case, our diameter of our circle will be 60 millimeters. So what we do now is we put our compass on radius 30. And we draw a 1,5 the circle. That means the diameter of the circle is now 60 millimeters. Good. What we're going to do now is we're going to draw a circumscribed hexagon to get to the different surfaces. A hexagon on the outside of the circle, or each line must form a tangent to the circle. That will also indicate the top view of a bolt or a nut construction. Okay, so what we're going to do now is we're going to draw our three surfaces view here, and we need the two pieces of material that's going to be joined to one another. This will indicate the one piece of material, and this will indicate the other piece of material. And now we construct the three surfaces of the bolt or nut construction. Let us make use of a bolt construction. We project the three surfaces. You can already see the three surfaces of our construction, and what we do now is we determine the thickness of the bolt. In a nut construction, we make use of a formula of 0.8 of D. With a bolt construction, we make use of a formula of 0.7 of D, if this information is not given information to your question paper or on your question paper. So what we do now is we determine that, and with a diameter of 40 millimeters, that'll be 28 millimeters. So the thickness of the bolt will be 28 millimeters, and we can draw the top of the bolt. Now what we need to do is we need to draw these little curves, and for us to be able to do that, we draw a construction line from that top point. There's 30-degree angle to the center line. That angle must be 30 degrees. That'll give us a point here, and that will be our first construction point. And what you do now is you draw a tangent to that top line. Draw an arc that forms a tangent to that top line. Now for us to be able to draw the other two is we use that line, and then we also project a line from that specific point where it crosses that line, and we repeat that construction on the other side. That'll give us these 2 points. Take our compass, reset it, and so that you draw a tangent to the top line. And repeat it on the other side. If you work accurately, that would have been the same distance. And the reason for these little curves is that little line that we draw there. That is actually a 60-degree line in this case, and we repeat it on the other side, and now we can complete it, our whole construction. And there's our bolt construction. Right, now what we're going to do is we're going to draw the rest of the bolt. That means we need the thickness of the bolt, and that is that 40 millimeters. So what you do now is you mark off 20 millimeters from the center line to that side, 20 millimeters to the other side, and you construct the two outside lines of the bolt. Good, but if you want to manufacture this component, you need to drill a hole in this component, but that hole has got to be a little bit longer than the length of the shaft. So we're not going to make use of any specific dimension, but we need the thickness of the jaw that we're going to use. And that is our next formula. That will be 0.1 of D, and that is a simple calculation. That means it's going to be 4 millimeters. And what you do now is you mark off 4 millimeters from that side, and also 4 millimeters from the other side, and you can draw the jaw size of this whole construction. Say for instance, our jaw depth, I'm going to go up to that specific position, then you draw the end of the jaw, and we as technical people know that the end of the drill forms an angle of 120 degrees. So that will complete the end of the jaw. And then we've got the screw thread. The screw thread is not going to be cut right up to the end there. It's going to stop a little bit earlier. And also our length of the jaw of the bolt is going to end up here somewhere, and it's been finished off with a 45-degree angle. Okay, now the beginning of the screw thread, and they end up there somewhere, and the completion of that will be indicated by a 30-degree line on both sides. But we still got a problem here. We got a dark line or a light line there and a light line there, and this is the bolt construction. So the outside of the bolt, because it's a machine component, will be a dark line. The inner lines will stay a light line, but that line there and that one there is part of the whole. So this is going to be a dark line as well. The rest you can erase so that it's a little bit more clear for you. Good. Now for the hatching of the component is, we're going to note now that we are not allowed to cut a bolt or a nut or the shaft, but we have, if we section something, but we can cut the component. That means our constructions our hatching will look like the following. That line will run up to the outside of the bolt. And we repeat it. I'm not going to complete the whole hatching process, just on the one side. But note now what happens to the line, the hatching line now. It's going to end up right up there. That part there is part of our component. It's not part of the bolt. The bolt's not being allowed to cut, or in other words, you're not allowed to hatch it, but that part is not part of the bolt, so the hatching goes through right up to the end of our construction. And same on the other side. Thank you very much.